So today's lecture will be started from the load calculation in per unit. Load can be modeled either series or parallel, obviously. And we already know if the loads are in series, load are modeled as series, then R per unit is equal to V square by S cos theta. If and X will be V square by S sin theta, right? If they are in parallel, so the cos will go at the bottom and the sine will go at the bottom. That's it, nothing else. So that is the thing we have already talked about, right, in our previous class. Remember?
Yes, sir.
Okay. So load modeling is done. So this is the formula. This is the math based on load modeling. So you actually can do it by yourself. Do not worry. Now, changing the base in per unit quantities. Changing the base. When only one component, such as transformers, is considered, the nameplate rating of the component are usually selected as base, right? Obviously, pretty simple. If one component is there, then the nameplate rating is considered as base. But what happens when you have several components, such as generator, transformer, transmission line, load, etc.? Everything is connected together in one circuit. Then what will happen? Which one you will take as your base? Which one you will take as your base? Normally, you can take anything. You can take any value, any component's value as the base, or general practice or the common practice are you will take generator's rating as your base. Generator rating as your base. Understood, everyone? Normally, generally. This is not rules, but these are the common practice. So are involved in circuit. However, the system base value may be different from nameplate rating of any particular component. Let's say your generator nameplate is different from your transformer nameplate. That means generator voltage is 13.8, but your transformer voltage is 15,400, right? So if you take 13.8 as your base, now this base will not be valid for this 15, right? Then you have to change the base, changing the base of per unit quantities, right? Then you have to change the base, not this. For these, for transformer, you have to change the base because 15 is not your base. 13.8, that is your base. You got my point, right? What I am trying to say here.
Yes, sir. We can.
Okay. The system base value may be different from one nameplate rating of any particular component. It is then necessary to convert per unit impedance of a component from its nameplate rating to the system base value. Then whatever the per unit impedance is given for any particular component, if the base are not same with that component, then you have to convert the per unit impedance of that component according to the system base value. System base value means whatever the value you are taking as your base. Generally generators. Okay. Let the old quantities are V base O, S base O. O means old, right? Old means that is already given in your ratings. That means ratings value. Let's say you have three components. Four components. One generator. Let's say you have five components. One generator, one transformer, one transmission line, another generator, another motor, right? So if all of them have the same voltage rating at their nameplate, then no worries, no problem, because their voltages are same, right? Rated at same. But if the nameplates are different means, let's say generator is running at a different voltage, but the transformer is rated. I'm not saying running, I'm saying rated at a different value. Transmission line is rated at a different value. Another transformer is rated as a different value, and the motor is rated as a different value. I said rated, not running. Then if your generator is running at a lower voltage, that means your transformer will transform the lower voltage, your transmission line will carry the lower voltage, and your transformer will again convert the lower voltage, and your motor will run at a lower voltage. Got my point? So that time you have to convert the bases. So let's say V base O, H base O, Z P O, Z base O. These are all your old quantities. That means your rated quantities. Okay, ratings, rated. So your actual is equal to what? ZPO per unit O, base per unit O is equal to ZP per unit O, V square, V base O square divided by H base O, right? That means your actual impedance will be what? Per unit into base. Which base? Your old base, right? Your actual is old base. So what is your Z base? V square by S. Obviously, these are all old. Remember, these are all old values. So now you got your actual value. Now you have to find out the actual value according to your new quantities. Now let the new quantities are V base new, S base new, Z PU new, Z base new. So your Z actual will be Z per unit new, Z base new, not M, this is M. Z P per unit new, and Z base equal to what? V square by S. All of them are new, right? So from these two, your actual is always same, right? Because it is actual. So this part and this part, can we write them same? Maybe the base is different. Maybe the per unit is different, but the actual is always same, right? So can we write them equal? Yes, obviously we can. We can write them equal. So Z per unit new, V square base new, S base new equal to Z per unit old, V base old square divided by S base old. So from there, can we take a, can we make a formula like this one? So the only formula you have to memorize is this one. So Z per unit new will be Z per unit old is into V old, V new whole square, S new, S old. Remember, so these are different. Remember, old is here up, S here is down. Base V base new is bottom at the bottom, and S base at the top. Remember, so this might be confusing, but you have to memorize this one. So when you are going to change the base, or when the base are not same, when the base is different from your nameplate rating, listen carefully. When the base value is different from your nameplate rating, you have to convert your per unit Z to new one. Maybe this is given at 10%. That means 0.1, right? J.1. It is given at J.1. Then you have to convert that 0.1 to the new one. Remember. So we'll do one example, then you will understand what is this. Example related to the change of per unit quantities in new base. Okay, the ratings of a generator are 300 MVA, 20 kV, R is equal to 10%, X is equal to 20%. Calculate the resistance and the reactance of the generator in per unit taking 500 MVA and 30 kV as base. Again, the ratings of a generator are 300 MVA and 20 kV, right? So ratings, these are ratings, right? Of one generator is 300 MVA, 20 kV, and the R is equal to 0.1 per unit. X is equal to J.2 per unit. These are all per unit because these are all percentage, right? Remember, percentage means per unit. Okay, these are the ratings that are given already for a generator. But you are not taking these ratings as your base. You are taking some other value as your base, maybe from some other generator. Maybe you have two generators. One generator is rating as this one, and another generator has a rating of this one. That is the rating that you are going to take as your what? As your base. হইতে পারে এরকম। হইতে পারে তোমার দুটো জেনারেটর আছে দুই প্রান্তে। one generator is rating as this one, that is your primary generator. Maybe this is your secondary generator. So you have to convert the secondary generator values according to the primary generator values as base, right? বুঝতে পারছি তোমাদেরকে? Did you get it? Let's say in your system you have two generators. One generator is this one that you are going to take as your base. But what will happen to the other generator values? So let's do that, right? Okay, everyone?
Yes, sir.
Okay. So your
Yes, sir.
V base old for this one, for your this generator, what is the base value? This one was the base value, but this is old one. That is the rating value actually. What is your H base old? 300 MVA. What is your R base or RP unit old? 0.1. What is your XP unit per unit old? 0.2. You can write J as well, no problem. You can write J or you can write 0.2 because you already know X means J, right? You have a J. Now your base V base new will be what? 30 kV. Your S base new will be what? 500 MVA. Now what will happen? Okay, what are the things you have to calculate? Calculate the resistance and reactance, nothing else. So what will be the new value of this one and what will be the new value of this one? That's it. So the R per unit new will be R per unit old, V base old divided by V base new whole square into S base new by S base old. That is the formula that I have already talked about, right? I just talked about that you have to memorize this one. Z means you can write Z, you can write R, you can write X, whatever. So your R per unit old is equal to 0.1, V base old is equal to 20, V base new is equal to 30 whole square, 500 divided by 300. So how much you got? 0.0741. That means this was for this particular ratings, but this is not your ratings anymore. Your ratings is now this one as your base. So how much will be R? This much is your R now. What about X? Again, same calculation. Okay, got my point, everyone?
Yes, sir, we get.
Okay.
Yes, sir.
Now the same next one. The rating of a transformer R, now the transformer R, 300 MVA, 15 by 300 kV, R is equal to 0.15 per unit, X is equal to 0.3 per unit. Calculate the resistance and the reactance of transformer in per unit, taking 400 MVA, 40 kV in the low tension side. That means your transformer ratings are 300 MVA, 15 by 300 kV, but you are using 40 kV in your generator. Got my point? Ratings is this one, but the actual, that means the base is this one. Got my point? বুঝতে পারছি তোমাদেরকে? The ratings is this one, but in practice you are using 40. It can happen, although it sounds pretty odd because it is 15 and it is 40. It is pretty odd, but for sake of math we will do it. For your, by the way, where is the base? Is in low tension side, right? Where the base is? Base is calculated. This voltage is high voltage or low voltage voltage? High voltage or low voltage? Anyone?
High voltage, sir.
No, low voltage. They said low tension side. That means this one. So 15 will be converted to 40, right? So
Yes,
your
sir.
low tension side voltage is given. Your V base new is equal to 40. V base new high tension. Now normally your high tension is not needed, but here if they say it, you can actually find out. See, if you give 15, you are going to get 300. If you give 40 here, how much you will get? 800, right? How to find out? 300 by 15, that means that this is the voltage ratio, into 40, so 800 kV. That is your base for high tension side. Although this is not necessary for our math. For this particular math, it is not necessary, But if I give you a big math, let's say you have a transformer, then you have a transmission line, then you have another transformer, that time you might need it. Okay, V base new for high tension side. High tension side is not needed for this math, but this will be needed later. So this is the voltage ratio, 300 by 15 into 40, it is 80 kV. How I got that? Like unitary method, 15 volt become 300 volt. So 1 volt will become 300 by 15 volt. So 40 volt will become 300 by 15 into 40, right? Equal to 800 kV. You got it. Now your old base, your old base is 15, that is your low tension side. Your old base of S is equal to 300 MVA, and your old per unit resistance is 0.15. Your old per unit reactance is 0.3. Your V base new for low tension side is 40 now, not 15. And your S base is 400, not 300. So you do not have to calculate using high tension side because this is not necessary. Or if you want to calculate using high tension side, you can just change the what? You can change the base, only the voltage 300, and this will be 800. S will be same because power remains same, and the per unit reactance and resistance, they are also same. Now your resistance per unit new will be resistance per unit old. Formula V old, V new. Which one? Low tension one, right? If we calculate the low tension side, then square into S base new, S base old. So 0.15, 15 by 40 whole square, 400 by 300. So you got 0.0281 per unit. Now, if you consider the high tension side, you will get something similar to this one. Only the value will be different, but exactly, see, only the value of the voltage will be different, but the other, everything will be same. Now for X, what is the X? X per unit new, X per unit old, V new. Obviously, these are all low tension side, that is the low voltage side, whole square, S base new, S base old, 0.3, 15 by 40, whole square, 400 divided by 300, so 0.05262 per unit. Understood, everyone?
Yes, sir.
So again, if you can consider high voltage side, you can actually do it, but for this math, this high voltage part is not necessary. Okay, it might be necessary later, but this time it is not necessary. You can actually find out using any method, any side you wish. But since your calculation, or since your low tension word is mentioned, so you can actually use low tension side. Now let's do a bigger one. Oh, by the way, a transformer is composed of 3 single phase transformer, each rated. A transformer is composed, that means is made of 3 single phase transformer, each rated 127 by 13.2 kV, 100 MVA, each. 3 single phase, remember 3 single phase transformer is used to make one transformer. All of them are rated at 127 by 13.2 kV, 100 MVA with a leakage reactance X 10%, that means 0.1. If the transformer is connected at YY, someone asked me a question, sir, what is YY, delta Y, and Y delta, right? Who asked me this? Some of you, right?
Yes, sir. I am asking, sir.
Okay. YY, delta delta, and Y delta connection. If the transformer are connected like this, YY, delta delta, and Y delta, calculate the new per unit reactance and new base in high tension side using base 600 MVA 20 kV in low tension transformer. That means at first your transformer, single phase transformers, 3 transformers will be connected at YY. That means your low tension part will be connected at Y, your high tension part will be connected as YY. Then here your low tension, that means the low voltage side will be connected at delta, your high voltage side will be connected at delta. In this case, your low tension part will be connected as Y, and your high tension side will be connected as delta. Got my point? Y delta. So you have to calculate the per unit reactance. That means this 10% will be converted to somewhere else. Reactance and new base. You have to calculate the new base as well. New base in high tension side using the base 600 MVA 20 kV in the low tension of transformer. Okay, let's do this math. For all three cases, the three-phase MVA rating will be S rated 3 into 100, 300 MVA. Why? Because you are using three transformers. One of them is 100. That means each of them is 100. So 3 means total power is equal to what? 300 MVA. Total power, I said. So 300 MVA. Again, this is not base. This is what? This is rated. So V base new is 20 because it is given. Okay. Now for one YY connection, since the Y connection line voltage is √3 of phase voltage. Again, see this one. In YY connection, since the Y connection line voltage is √3 of phase voltage of the three-phase rating of the connection is √3 into 127 kV, that is for Y, divided by √3 into 13.2 kV, that is Y, 220 kV Y by 22.8631 kV Y. You got the voltage rating because both of them are YY. So Y, if you connect them YY, these voltage will be multiplied. That means, see, this 127 is Y. This 13.2, this is also Y, right? So these 127 will be multiplied by √3. These 13.2 will be multiplied by √3. So your three-phase rating will be what? This is your single-phase rating. So your three-phase rating will be what? 220 kV and 22.8631 kV. Got my point, everyone? Y means what? Y connection means your voltage will be multiplied by √3. This is also Y, this is also Y. So 127 √3 and 132 also √3. So this is your voltage rating for three-phase. Now your base voltage in high tension side. Base voltage in high tension side. Base voltage. What is your new base? What is your new base? 220 divided by 22.8631 into 20. From where this 20 has come from? From where this 20 has come from? From there. This is your old base, right? No, this is your new base, sorry, not old base. This is your new base. So new base is equal to what? 20 kV. So your final high voltage side new base will be what? This is the transformer rating, but these voltages are not real. Not real means not actual. So your base is 20. Got my point? So here, if you give 22.86 volt to this transformer, you will get 220 volt. Now, if you give 20 instead of 22.86, so how much you will get? You will get 192.5. Obviously, 22 become 220, 20 become less than that, right? You got it? So your voltage at high voltage side will be 220 divided by 22.8631 into 20. So that is your new base. So 192.5 kV. Now your XPU new, XPU old, V base old, V base new, high voltage or low voltage doesn't matter because it is per unit, everything will be same. So S base new, S base old. So 0.1, 22.86, that is your old base. Old base means this is your old base. That means after connection. 22.8631, V base new is equal to 20 whole square, 600 by 300 because 600 was your old base. 600 is your new base and 300, that means after connection, that becomes 300 MVA transformer, right? Because 3 100 MVA transformer, if you connect them together, if you make them 3-phase, that becomes 300 just after connection. So that is your old base. So 600 is your new base, 300 is your old base. 22 is your old voltage, 20 is your new voltage. So this is the value you are going to get, 0.286, 0.2614 per unit. That when you calculate the low voltage side, if you calculate the high voltage side, again you will get the same value. Now for delta, no root 3 will be multiplied, because 127 will be 127 and 132 will be 132, because both of them are delta, so no root 3. Now your V base new for high voltage side will be what? 127 divided by 132.2 into 20. That means if you give 132, you will get 127, but you are not giving 13.2. If you give 13.2, you will get 127. But if you give 20, you will get more than that, right? That is how much? That is this much. So that is the objective of this calculation. That is, if you give 13.2, you will get 127. If you give 20, how much you will get? So this is your new base. New base for high voltage, 192.42 kV. Now your X per unit new is equal to X per unit old, V base old, V base new, obviously low tension, and S base new, S base old, V base old is equal to 13.2, V base new is equal to 20, and your S base new is equal to 600, X base old is equal to 300, so 0.0871 per unit. Again, if you calculate using high voltage side, you'll get the same value. Okay? Now that was your delta. Now what will happen, anyone? What will happen if I use Y delta? Anyone? What will happen if I use Y delta?
It will be root 3, sir.
Which one will be root 3?
Sir, why?
Y. That means this part will be multiplied by root 3 and this one will remain same, right?
Yes.
Okay, yes. Let's see. So your 127 will be multiplied by root 3 and 13.2 will be same. So this is 220 and 13.2. So your V base new is 20, right? This is for low tension. So if you give 13.2 at your low voltage, you're going to get 220. But what will happen if you give 20 instead of this one? So how much you will get? You will get more than 220, right? So how much is this? 333.33 kV, right? Now again, the same value, same calculation, everything will be same. Okay? Got it, everyone?
Yes, sir.
Yes, sir.
Okay. Now let's take 1 or 2 minutes of break, okay? I mean, I have to take some water.